And so thank you, Debbie Bronk, for opening the meeting last time. And I think it's great that these presentations are recorded. And Alice, thank you for sending those links around. It was nice to listen to the agency reports and gives you an opportunity to hear from people that we hear from just once a year or so. And it's nice to hear some new voices, new perspectives on things. So let's get it rolling, Doug.
Well, thanks, Dennis. Welcome, everybody. Today we're talking facility updates from the various facilities that are essential to the success of the UNOLS community. Last year, we had very in-depth presentations that bring people up to speed in these different facilities. Yesterday, it was sent around a read ahead that kind of gave you that background and also the links to last year's presentation. So this year, we're hoping for short updates, no more than 10 minutes from each one of the facilities to kind of tell you about any changes, updates, and some of the challenges they may have dealt with in the last year. So I look forward to those for that information coming around. As we've talked about in the past, please just, if you've got a question, raise your hand in Zoom and we'll recognize you. Keep your back. It'd be nice if you can keep your mics muted when you're not talking so that we don't get background noise. This makes it harder for the speaker. And just a reminder, everybody, we are live streaming this and we're also recording this. So just be aware of that. Nobody's calling in from any phone today, so we don't have to worry about any phone numbers being displayed because we are sensitive to make sure we don't give out any personal information as well. And with that, I think we'll get started. And the first up is for Kaya Johnson from give us a van pool update.
Great. Hello, everyone. Alice, do you want to pull it up on yours, or is it easier if I pull up the slideshow?
I have it pulled up. I've said I've started sharing. It's thinking about it, obviously. There it goes. Okay.
All right. Well, hello, everyone. Good afternoon. This should be fairly quick. As Doug said, this is just UNOLS or updates to the UNOLS van pools, not the whole program overview as we did last year. So if you can hit the next slide, Alice, that'd be great. We have two pools, the West Coast Van Pool here at Oregon State University, and we have one at the East Coast. Next slide, please. That is at the University of Delaware, and Tim Deering manages the East Coast Van Pool, or ECVP. All right, next slide, please. So basically, the updates I have for everyone is just kind of an overview of what COVID impacts we experienced, some regulation changes or clarification that we received from the Coast Guard, a new van that we had built. Our red vans, we switched LSCs to a new unit, and some other projects that we accomplished here at our facility. Next slide, please. All right, for COVID, just like everyone else operating ships or pools, there's been a series of challenges with ship schedules changing and trying to accommodate that. Normally we structure the schedule so it goes from one ship to another and as efficiently as possible. So if one ship slides, 3 weeks, that has a trickle-down effect that's hard to navigate. Just shipping throughout the U.S. and internationally has been challenging. We have a few vans stuck up in Alaska right now, and we're going to have to put them on a ship, and all of the ports are backed up. So we're not sure we're going to see those back anytime soon. And we've had to be pretty creative about coming up with solutions. We've definitely worked with our partner institution, the East Coast Van Pool, a whole lot. So Tim Deering, thanks a whole bunch for that. And we've got a need for a general purpose van right away because of our van stuck in Alaska. So we reached out to our OSU institution, MarSSAM, who has what they call an MST van. And you can see it in the picture to the right there. So they were kind enough to gut out all their coring equipment, and we're using it as a general purpose van. It's actually going to go out on the Sally ride here. and shipping out tomorrow. So we're able to meet all our needs, but had to think outside the box a little bit. All right, next slide, please. A biggie for this year was receiving clarification about the regulatory requirements. And Doug helped out a whole bunch on this. So Doug, thanks a lot. The safety committee reviewed a lot of the documents. ONR, Rob reviewed those. But we did receive a letter back from the Coast Guard, which clarifies that our lab vans do not have to meet that higher portable accommodations module standards, or PAMS as they call it, which has a much higher fire rating, more safety equipment. And that was a real big issue, because had those regulations been applied, all of our lab vans throughout the fleet would not meet that spec. So that was a real big accomplishment. So our lab vans are good to use on any US flagged vessels under subchapter U. So that's written, that's good to go. The vans do have to be installed in the sheltered areas on ships, and they cannot be staffed in heavy weather. The Coast Guard officer in charge of marine inspections, or OCMI, does have the final authority, and they if there's any alterations or things that need to be worked out, they are the go-to person for that. All of the MARSSAMs were informed of this information via email that Doug sent out on the 1st of February in 2021. But if anyone doesn't have this policy letter, feel free to reach out to me, or Doug has that as well. And just to be clear, any accommodations vans or PAMs, as ABS calls them, do have to meet that higher standard. So they are different from lab vans. All right, that's it for the regulatory update. Next slide. We do have a new cold van. It's kind of been in the works for a little while, but we have it on site. We've ran it through a series of tests. Here are a few images of it. It's shiny and new. And we'll be sending it out on the final Oceanus cruise, the Reimers state-funded trip. So we should have some good information about how it handles at sea. Next slide. We have switched or in the process of switching. We wrote a proposal for new Hydex liquid salination counters, or LSCs, for 2 of our rad vans. And we're really excited about these. We, in last year's meeting, kind of solicited information from folks, and we got a lot of feedback. We reached out to all of our previous rad van users and asked them if this would be a good tool for them. And at OSU, we've got a few offices that use these LSCs. So after getting a lot of feedback, doing a lot of research, we decided to go with these units that are smaller. They don't have an active radiation source. They use a logarithm to calibrate it. So we're really happy about this, and they're going to replace really big, clunky old LSCs that are no longer being supported. So we've got 2 of those that we're about ready to install, but due to COVID delays, Hydex is a little backed up with their servicing, but we'll have these in our vans very soon, and they'll be getting use early next year. All right, next slide. We're continuing with a few projects. These are actually old photos, but I didn't have any recent ones. Last year and this year, we painted 2 vans each year to kind of refurbish them, kind of clarify some of the stenciling and conflicting labels that we had on some of the vans. So that's a process we're kind of each year kind of trying to chip away at. So yeah, that's what it looks like to repaint some vans. Next slide. That's pretty much it. For any questions, you can always reach out to me at the West Coast Van Pool, or Tim Deering at the East Coast Van Pool. There's our contact info. There's websites for both of the pools. Next slide, please. Right. Any questions from anybody?
Really a question, Kaya, but I just want to mention and give kudos to the East Coast van pool for sending coal vans down to Lumpcon after the hurricane. They were in need of some help, and we were able to help them out that way.
Yeah, you bet. Thanks for mentioning that. Rose reached out to both of us, and it turned out Tim's a whole lot closer and he had one ready to go and was able to kind of help those folks out. So great use of our vans to help out kind of in a different area.
Hey, Kaya, Dennis here. You said that vans can be used if installed in sheltered areas. What constitutes a sheltered area? For example, in the Fantail or on the O1 or places that we usually see vans.
I guess it depends on the ship. Typically not on the bow. Way back, the Healy put one on the bow, and it was crushed by some green water wave that came over the top. So yeah, an area where it's not getting the full kind of brunt of weather. So usually aft, or if there's some sort of structure that protects it.
Thank you.
Yeah, usually tucked in behind the deck house, or usually on the fantail of the boat behind the rest of the deck, the ship's interior structure works out fine.
Thank you.
Sarah Fuller had a question.
Hi, yeah, just more of a comment. I just want to make sure that one of our missteps at Hui with our rad vans was we had our LSC on the sole of the container because they're so big and heavy. And Kai, I just want to make sure that that got passed along to you to make sure that you guys have them raised off the floor because we had a flooding incident and ruined one brand new LSC. So learn from our mistakes and make sure it's up off the sole.
Well, thanks, Sarah. Yeah, I recall that incident. I believe someone hooked up the potable fill on the drain line and it filled up the van accidentally. Yeah, sorry to hear about that. Our vans will be up higher, and that's partially the advantage of the smaller high decks units, is they're just a way smaller, and they'll be up at the countertop level.
Okay, well, thanks very much, Kaya, for that update, and also for Tim for his input into it. Very informative. Thanks for the great job you guys do to help make science happen behind the scenes, and this runs pretty smoothly thanks to the work you guys do. And also thanks for being within the time frame. So great start.
Right.
There's
So,
a question from Rob.
oh, I'm sorry, Rob.
It's in the chat.
Sorry, just wondering, do other agencies use the vans at all, or is it available to them?
Yeah, great question, Rob. Yes, absolutely. Anybody in the academic fleet under any funding source can use the vans, including the Office of Naval Research. And thank you again for some support to the van pool for some new LLCs as well.
And there's a question from Byron Bloomquist, who asked about clarifying whether the vans that they use he does a lot of climate research and atmospheric research in the bow of the ship where they have towers and things like that. They're asking those, and including privately owned vans, are they no longer allowed?
I would check with your OCMI and get a copy of the letter that was sent to UNOLS that I mentioned in the presentation. If you don't have it, I can provide you a copy, or Doug can. But it's recommended you take that letter, talk to your OCMI, and they can clarify what's accepted and what's not.
Okay, thanks, Kaya. Okay, we're going to move on to the next one. Next, we're going to have winch pool updates from both the West and the East Coast winch pools. We're going to start with Aaron Davis at the West Coast Winch Pool first. Aaron, you with us?
There we go. I was just waiting for the presentation to show up. Can you hear me okay?
We can.
Loud and
Okay.
clear.
I'm presenting for the West Coast Winch Pool operated by Scripps Institution of Oceanography. Next slide, please. Next slide, please. Okay, we provide an inventory of oceanographic winches and other equipment that can be shared use. We keep it in good repair, and we add to it and take away with it from it to better support our customers. We also provide technical support such as cable and wire rope spooling, training, repairs, and so on, engineering. Next slide. How it works, we're funded by NSF. Our customers communicate their needs to us, usually with an email or a phone call. We match their needs to a piece of equipment that we have, hopefully. We get it to and from the job site or vessel as required. And this is usually at no cost to the customer if it's for NSF funded research. Others chip in with a day rate or a rent that we charge. Next slide, please. So what we've been up to. One big thing we've been up to is trying to upgrade some of our winches. We have a lot of TSE spoolers in our community. We have about 5 of them in our pool, and they're used primarily for reeling up moorings, although they were actually designed for tensioning power lines on dry land. So as a result of this much heavier duty use that they see, we have major parts fail, well, wear out quickly. And because they're not made for use at sea, they can lift a lot of weight, but they're not made for the dynamic loads. So we've been aiming to replace these for quite some time. In 2020, we added this Hobble mooring winch, which was designed to look and act just like it, but it is a proper marine winch. It has more pull. It can withstand quite a bit more load, 20,000 pounds. And we've got a lot of feedback, a lot of good feedback about it. They're very easy to use, which was a concern. The TSE spooler is dead easy. You can walk up to it and with a 5-minute tutorial operate it. We wanted the mooring winch to be the same way. Users like the tension meter that the former spooler didn't have. They also like being able to deploy moorings anchor first and recover them anchor last whenever it's convenient. We always discourage people from doing that with the TSE spoolers. The level wind also passes mooring hardware nicely. And a surprise is that it can automatically spool any tension member between about 1/4 inch and 3/4 inch. And it's also fitted for slip rings. So we've actually used it several times as a conventional winch, which has been nice. Next slide, please. It hasn't been without its problems. This is a brand new piece of equipment, and so there's been a little bit of growing pains. When we in the sea trial, we found it was rendering line a little bit. If you lifted something heavy, stopped, and then started lifting it again, that was actually a setting that we had to change on the main motor drive. So we got past that problem. We started receiving complaints that the control lever was broken. We would test it, there's nothing wrong. All the signals going into the computer are fine. Then we started getting complaints that it wasn't paying in and out on the first try. The East Coast Winch Pool has had similar problems, which I'll let them elaborate on. This points to a control issue, probably just calibrating their controls. The winch is actually at Hobble engineering or Hobble getting those controls looked at right now. We also had on its last cruise, we also had a fault in the main motor drive, which we couldn't recover from. And we had to find another way to do the work. Hubble's looking into that as well. And lastly, we were disappointed to find that the dynamic braking resistor it has is not in fact waterproof. We were told by Hobble that if it gets wet, then it could short circuit. There is protective circuitry to prevent any damage to the machine or personnel should this occur, but we don't want an interruption in the operation. That could be very hazardous. So it's currently being fitted with a waterproof dynamic braking resistor. Next slide. We've also been updating our light duty winches. The winch on the left is a CMAC winch. It's getting kind of dated. There we have two of these. They're not Appendix A and B compliant. So a few years back, we got the winch to the right. This is a Hobble light duty winch. It has a tension meter, which is nice. It can automatically spool any line between 1/4 and 3/8 inch. It has more pull than its predecessor, and is of course Appendix A and B compliant. It was not. The next slide, please. It wasn't initially received very well because unlike its predecessor, one did need to get to know it a little bit, learn its functions and whatnot. But after a little bit of a period of growth, the users seemed to like it quite well. Also, not without its issues. Let's see, it has a loud cooling fan. I actually specified that it be air cooled, so it was more self-contained. One just has to plug it in and it's ready to go. But as a result, this cooling fan is actually quite loud. And in fact, recently we're told that it was louder than is safe. So this is currently being fitted with, I designed a silencer for it, and we're going to try it out with the silencer. If that doesn't work, we're going to put a water cooler on it. What else do I have? Oh, fragile protruding things. Yeah, it does have a lot of, you can see on the top of this winch, there are gauges, there's a vent, sensors kind of sticking out. They unfortunately do get knocked off during shipment and whatnot. So we've had some problems with that. It affects the winch's operation. And so we've put guards around a lot of things. They're not shown in this photo. And we also make sure that we ship the winch with replacements for all these things so that they should show up to the ship damage, they can be fixed. And trace metals. This winch is often used as trace metal, as a trace metal winch. The sheave on the level line that you can see there is aluminum though. So before each trace metal deployment, we paint it. But we've had problems with the paint actually flaking off, which is not making the trace metal folks happy. So we're actually going to replace those aluminum parts with some plastic parts in the near future, so we don't have to worry about that. Next slide, please. So in the last year, 11 different funding agencies have been using our equipment. They've been used on 11 different vessels. Many of these vessels used our equipment several times this past year. And we've done an awful lot of spooling this year. We did spooling on 7 different vessels, sometimes more than one operation. So our spooling gear is getting used. Next slide. I've done quite a few engineering projects this past year. We replaced the level wind on Robert Gordon Sproul's -3 winch, so its tension member could be used with a lower safety factor. Robert Gordon Sproul didn't have any hydraulic diagrams, which is problematic when we got a new chief engineer. So I made diagrams for its hydraulics, made a new fire plan for Roger Revell. Roger Revell came out of its midlife refit not too long ago, and it had a new crane. One feature of this crane, it's got a sheave in the middle of it that allows us to do coring from the winch down below, using the winch down below. This requires a turning sheave that in the new crane is not up to the task. So I'm designing a replacement sheave for that. I helped our res techs design a new CTD cart. What else? Evaluated the Roger Revell's deck a couple times. We used the geotraces system for the first time on the port side, so I evaluated that. It was okay. And made some test procedures. We of course test our handling systems regularly, but we thought we could test them in a manner that more closely mimicked their use at sea. So I made some new test procedures, and we tested the starboard side handling systems on the Revell and Sally Ride. We'll get to the aft systems later this year, hopefully. Next slide, please. And that's it. If you have any questions, give us a call. Any questions?
Great, thanks, Aaron. Anybody have any questions for Aaron?
Yeah, just one quick one if I could.
Sure.
Aaron, have you noticed any problems with your mooring, your new Hobble mooring winches and the level wind motor mount?
Nope.
Okay. We should talk about that if you haven't been made aware of it, but we've seen play in the motor mount. And there's going to be a modification to the way that motor and gearbox mounts to the winch itself.
Okay. Yeah, I've gotten those emails from Josh, but I will have to discuss that with Hobble.
Okay, very good.
I just want to mention to everybody that Aaron, he works for the fleet. I know all these projects are SIO specific, but SIO is a huge player. But Aaron is available for advice and consultations across the fleet, just so everyone knows that if you have issues, he's our engineer, or one of our engineers, but he's full-time engineer for the fleet.
Thanks, Jim. And that's a great segue over to Brian, who can give us an update from the East Coast Winch Pool. Thanks very much, Aaron. That was a great update.
All right, well, good afternoon, everyone. Please bear with me because I'm not too Zoom savvy, but we'll see what happens here. That one, share. And run.
All right, we can see it.
Okay, are you seeing the presentation mode or the? There we
Yes.
go.
There you go.
Okay. All right, let's see how this works out. So, good afternoon. I'm Brian Guest, and I am manager of the East Coast Winch Pool. We're located at the Woods Hole Oceanographic Institution in Woods Hole, Massachusetts. And by now, I'm sure all of you know who we are and what we do, but I will give you a brief summary of our operation and some of our future goals. The winch pool is made up of 2 full-time and 1 half-time staff member. We make ourselves available to our users 24 hours a day, 7 days a week, via email, by phone, you name it. Whatever it takes to get in touch with us from at sea, we're there to talk to them. Jamie Haley is our shop steward and mechanical technician responsible for the pre and post cruise preparation of all of our winches, blocks, slip rings, any of our borrowed equipment. Jamie also handles winding the strength members on our systems in the shop and any mechanical modifications and repairs that are required. Josh Eaton is our engineer and maintains all of the electrical systems of our winches. He works closely with the vessels, the users, and the vendors to ensure the firmware, software are current and working properly. And as a member of the UNOLS Safety Committee, he makes sure our systems comply with Appendix A and B. My responsibilities include overseeing the budget with an eye on keeping costs down as low as possible without sacrificing the quality. I handle all the scheduling, the equipment for both NSF funded users and non-NSF users alike. Part of that scheduling is setting up all of the shipping requirements to and from ports. I began my career at Hui back in 1983 as an electronics technician, and I have logged more than 85 cruises sailing as chief scientist numerous times. It gives me a good working knowledge of how our vessels operate and what we need to provide in many aspects of mobilizing, demobilizing for work at sea. I often work in the shop as well as another technician. I provide wire winding services for both UNOLS and NOAA vessels, and I travel to ports to assist with setups and breakdown of gear when necessary. And we also utilize the services of other Hui engineers, technicians, and fabricators when needed. We have a great resource for that here. When we get really busy, we can call on quite a few people at Woods Hole if need be. Our shop is a dedicated space for the winch pool. It provides about 2,000 square feet of floor space for both maintenance and storage of our systems. It's equipped with a 5-ton overhead hoist, UNOLS 2-foot on center bolt pattern built into the floor, and a dead head for static load testing for up to 8,000 pounds. We currently have 14 winches in-house, everything from what we call ultra lightweight to our heavy duty, which would be the mooring winch that Aaron described earlier with about a 10,000 pound safe working load. Presently, we're currently working closely with InterOcean in California on the fabrication of a new small portable trace metal system that will be added to our inventory, and will spend most of his time at Skidway Institute in Savannah. Worth noting is that this winch is based upon a design by Jamie and Josh, and has been licensed to InterOcean. One of the most interesting features of this winch is the placement of the motor and gearbox within the drum itself. This minimizes the footprint and greatly reduces the need for a heavy framework, allowing us to build a small yet strong winch that can be mounted to smaller vessels like the Savannah. We have a couple of tensioners for applying tension during winding operations. We also have access to a third, which is a Hui-owned system, but it's available to us. It's diesel powered. It makes it very convenient when shore power is not available. We have an assortment of blocks. It would be nice maybe to increase that assortment, but so far we've been able to supply all the needs. And then we have a few assorted other items, not necessarily individual loan out items, but things that make our jobs easier. We have turntables, which I'll show you later on, that mount to our winches and allow us to adjust the fleet angle of the winch. If you have limited deck space, and we know we always seem to, it allows you to offset the winch off the center line and turn it in increments of about 2.5 degrees to point to your overboarding block. And this actually makes great savings of deck space. It's been very handy, and I believe we're going to be building one for Aaron on the West Coast to try out with one of his winches soon. We also have a couple of MRUs, motion reference units, some slip rings, and a couple tensiometers for our pulling against the deadhead. This was popular the last time around, so I thought I would show it again. This is a winch mounted to one of our turntables that was designed by Jamie and Josh as well. Any part of that rotation, it can be locked in place. Just drop in a keyway that goes in this on the inner part of it, and it locks the winch right in place, and you're good to go. Okay, I'm losing my place. So we try to make ourselves very accessible and easy to access to our users. We have a website online that people can log into, and they can log into and fill out a winch request form that'll get the ball started for anybody that needs a piece of equipment. Once this is all filled in, it usually provides us with almost all the answers we need. But we certainly do talk with our users later on along the process prior to their cruise to figure out exactly what we can or what we may need to provide to them. They can also see how equipment is scheduled. Some people use this that are repeat users of certain systems. They can log in, they can see if it's tied up or busy. It lets them see how things are going and what's available to them. And now to the future of what we're looking at. One of the biggest problems we've run into lately is the winches are heavy. And 2-3 of our systems exceed the capacity of our overhead crane. We have to be very creative to get a system out the door because of this limit in capacity. So we have approached the Hui facilities office here and have gotten approval to go ahead with a larger 7-ton capacity overhead. And we're looking to have that installed in early 2023, if at all possible. This is the winch I mentioned earlier. This is the trace metal system being built at InterOcean. As you can see, the motor in this one is sticking out just a tiny bit, but you don't see those heavy motors and gearboxes protruding on the outside of it. This allows the footprint to be as small as the lightweight winch that you saw in Aaron's earlier photograph. And it also has significantly more torque and lifting power. It's the first time for this winch, although there are 2 others being built for the University of Vermont, not related to the winch pool. but of this design. One other thing that's something that probably should have been installed from day one of the winch pool's formation is a means of doing static load testing on our winches. This is a picture of a system at Hobble that they use just for that purpose. It allows them to place a weight underneath of the tower. There's a block that's a little hard to see at the top of it, and allows the winch to go through a range of motion, utilize the brakes, and test it within its limits to verify the operation of the system. Currently, the only way we have to test the safe working loads of our winches is to pull on a deadhead with a tensiometer in line. So there is no movement per se. It's simply placing a strain on the load cell. And this would allow us to actually operate it. Aaron touched on some issues he's seen with the mooring winch that they purchased from Hobble. We have one of those systems, and we had a significant problem with it in its first deployment with an AUV, ROV with our deep submergence lab. I won't get into a lot of the details, but what happened was as the A-frame was paying out, the winch operator was keeping it at a given height off the deck. He stopped the joystick and then proceeded to continue. When he did that, the winch free spooled out, dropping the ROV to the deck and then into the water. Hobble's been very good about working with us on that, and we're getting that problem sorted out now. My winches are getting loaded on the flatbed this week and will be shipped up there. They already have one of Aaron's winches there, which is an identical twin sister of this one, to see if that one has the same characteristics or problems. But using something like this system here with it doing a static test, we may have seen that prior to it going out to sea. So that's where the future is for us in the short term. Yes, we need to increase the winches in our inventory. Some small winches would be great, like Aaron's smaller winches. The ones we have now are 10 years old, 12 years old. I have one that's 25 years old, and we can't get parts for any longer, including the TSEs, mooring spoolers that Aaron spoke about. We make do, we rebuild parts as we have to, but they're past due. They need to be replaced in the coming years. And hopefully we can put some new small winches and potentially add to our mooring spooler inventory in the future. So thank you very much. I hope I didn't ramble too much. I hope I provided some information that you found useful. And if you have any questions, I'm happy to try to answer them.
I've got a real quick one for you, both you guys, Aaron as well. We made a major investment in SF as with Hobble. Are we okay with Hobble? We've had some problems, but I think their customer service is good. What's your feeling?
You want to go first?
Yeah.
Okay, well, I will go first, and I would say that Hobble's customer service is by far the best I've seen anywhere. They are 100% committed to making the best product they can possibly make. That being said, these newer systems with the electronic controls, they have to be thoroughly tested in every possible scenario before they go out the door. They're not like the hydraulic systems where it's a valve and a control and a pump where you know what's going to happen. It just, you push the lever forward, fluid flows, it has to move. These have these little mystery black boxes full of electrons, and it makes it hard to trust them sometimes. Do I think Hobble is capable of handling these problems? Yes, I do. It's unfortunate that this happened during a cruise, but I do have faith in their ability to produce a good winch. But I think I will change the way our pre-cruise testing of new systems goes in the future.
So I agree with that sentiment. When we have a problem with the Hobble product, no matter what time of the day or night it is or what day of the week, they pick up the phone and they get on it, and they're not charging us anything for it either. And that's something that so far no other manufacturer is willing to do. I mean, at any rate, I'll leave it at that. But I agree, we need to have more testing, and that's something we should probably wrap up into the price of the winch in the future. Actually bringing these things, because we tested them at the factory. We lifted weights in that big tower that was shown earlier, and started and stopped and everything, but clearly that wasn't enough. So in the future, in addition to just having our sea trial was an actual cruise. If that wouldn't have went well, then that scientist would have been sore. But in the future, we should try to find a way to actually test them more rigorously at sea before they're released into the wild, as it were. And like I said, have Hobble on site and wrap that up in the price of the winch.
Thank you.
I will say too that while I am a big fan of the old school hydraulic systems, even though they're messier, and less of a fan of the complicated computer controlled type systems, one big advantage we have had is Josh has worked in network hubs. He started out trying to convince me to do it on one of our McCartney winches some time ago. He wanted to do all of them, and Josh likes his toys. So I agreed to allow him to do it to one. And on the very first cruise, it paid for itself. They had a little problem with the auto render feature. It was nothing serious. It was only that the specifications we received from the user were less than what they needed. With the network hub, Josh is able to sit at the computer at his desk, log into the winch on the vessel using the internet, look at all the firmware, software, and logs, and make adjustments from the desk. This is something we're putting in all of the McCartney winches now. We've also, in the design, requested it in any designs with Hobble, our interocean system. This has really been a money saver and a time saver, and it's kept science going at times when otherwise I don't know what they would have done. It would have been complicated to explain to someone how to make the changes that he was able to do from his desk. So that's one benefit of these new direct drive systems.
Great, thanks, guys. It was very informative. Thanks for all the great work you're doing too. I'm sure most of your problems always come up when it's late at night or on the weekend too. So thanks for always being there, ready to rock and roll to keep science going at sea. With that, we're going to move on to OBSIC with John Collins.
Good afternoon, everybody. Got a short presentation here, just describing what OBSIC has been up to over the last year. Next slide, please, Alice. So just a quick summary here of what we've been doing since November 2020. We've supported 4 substantial experiments, one for Jim Geraghty in the Southwestern Pacific, one for Margaret Betcher on the Gophard Transform Fault, which is 4.5 degrees south on the EPR, and then 2 very big active source experiments on the West Coast, one for Pablo Canalis offshore Cascadia, and another one for Lindsay Worthington along the Queen Charlotte Fault. So for those 4 experiments, we had 6 cruises, and I think for sure the ports for Geraghty and Betcher were impacted by COVID. Those cruises were quite long. We did have to do a substantial amount of pre-cruise quarantine for the Gophard, Betcher, and Cascadia legs. Not as much, of course, as say John Kemp's mooring group. And the one substantial impact for us as a facility is we had very limited opportunity for in-house training for tech pool personnel and for technicians and engineers from USGS Woods Hole here on the Quissit campus. Next slide, please, Alice. Okay, just a brief summary of the actual individual experiments. In in late 2020, we did the Jim Garrity Pacific Array experiment that had a 2-week quarantine before that, but we recovered 30 Scripps broadband OBSs. And we did have Justin Smith from the tech pool participate in that cruise. And by all accounts, he did a great job. Next slide, please, Alice. And then in January, February, we did the Betcher GoFar Leg 2 OBS recovery and redeployment. That cruise suffered a slight delay because of COVID-related problems. That cruise went from San Diego all the way through the canal into Port Everglades. And again, it had a 2-week pre-cruise quarantine. Again, HUI and Scripps OBS teams, both institutions participating in this cruise. And we recovered 49 OBSs and deployed another 51. And 30 of the OBS deployments were dropped off the end of the wire, where the location was assisted by a USBL system. And I think that's something that's going to be requested in the future. That was the second year we did that. And I think we were able to get very good locations for the OBSs. We had very specific targets to hit, and it worked out very well. We started off those wire drops using a MASH pool from the US East Coast winch facility, but we actually quickly moved over after just one wire drop to using the Thomson winch. Next slide, please, Alice. Okay, so from there, we went on to the Canalis Cascadia experiment. That experiment was scheduled to go in 2020, but was delayed because of COVID. This was a substantial experiment, right, involving OBSs, multi-channel seismic, and over 700 land stations. It comprised 2 legs, with the Lancet deploying OBSs on a very, very short leg, Newport to Newport. Again, that had a 2-week quarantine before that. And then the second longer leg used RV Oceanus to recover OBSs and redeploy them. So we use 60 HUI and Scripps short period OBSs for a total of 120 deployments and recoveries. And by all accounts, that is a spectacular data set because of the location of the experiment. The data are subject to Navy screening and very likely data redaction. So those data are not back at Scripps and HUI yet, but should be back here early next week. Next slide, please. Okay, and then we moved north to the Queen Charlotte Fault. You can see on the map on the right there, the location of Ketchikan. That was another experiment delayed from 2020. This was again a 2-ship experiment, OBS and multi-channel. For the OBSs, we used the Canadian Coast Guard ship Tully to do the OBS deployments and recoveries. And I have to admit, we were initially very worried about trying to get 60 OBSs on board the Tully, and but it worked out to be it worked out extremely well. The Tully crew added some dunnage to the back deck to cover up a whole bunch of strange blisters they have in their back deck, so we could have a level deck to store all 60 OBSs. And again, that data was subject to Navy screening, but the Navy concluded last week that they would not redact any data. Next slide, please. And from there, we moved into another component of Lindsay Worthington's experiment. I just described the active source component, but there was also a broadband 1-year-long component. This was also delayed from 2020, and we used the Lancet in and out of Ketchikan back into Seattle to do that deployment. No pre-cruise quarantine, 28 HUI and Lamont broadband OBSs, and that data will also be subject to Navy screening. So next slide, please, Alice. A quick look at what we're, what we have to do later this year and next year. Next month, we deploy 25 broadband OBSs for Gabby Lasky. That experiment has also been delayed, but for reasons other than COVID. that's in and out of Honolulu. Early January, we go back to the GOFAR transform. And that cruise was originally scheduled for San Diego to Tahiti. It looks right now that it might be San Diego back to Honolulu, adding another 4 days of transit to that leg. And then we go through, we have an active source experiment, again from Langsett, in and out of Manzanillo. And we come back up to the Pacific Northwest, deploy some broadband OBSs for Will Wilcock and Axial, and deploy some short period OBSs also. And then we go recover Lindsay Worthington's broadband OBSs. So we have 1, 2, 3, and then we have 4 cruises on Langsett next year. And then the Langsett goes through the canal and we do an active source OBS experiment for Jin Lin in and out of San Juan. So we have a busy year next year. Next slide, please. And then just the usual 2020 concerns, possible COVID-related restrictions on foreign ports, shipping. This came up earlier in the meeting. Certainly, I anticipate there'll be cost increases and delays to shipping, and supply chain issues are substantial. Electrochem, which is a big primary lithium battery supplier that all the OBS groups use, they are now quoting basically a 6-month delivery time for their OBSs. So we have to factor that in terms of how we schedule our experiments. And that's my last slide, but I would like to kind of finish on 2 kind of very positive pieces of news. We submitted a mid-scale research infrastructure proposal this year, and we just heard in September that we are going to receive, we're going to be funded at the $6.5 million level to build another fleet of broadband OBSs. And I think that's going to really cut down on the delays PIs are experiencing in getting their experiment into the water. So that is super exciting for us. And we also are going to make some progress on what we call rapid response. Over the last couple of years, OBSIC has had to turn down some requests from US investigators to instrument, say, very large earthquakes offshore Alaska, south of Cuba. And we've also had to turn down a request to put some instruments off the Canary Islands for this ongoing eruption. Well, using USGS funding that Nathan Miller across the campus here pushed through, we will take possession shortly of 10 dedicated OBSs that will be dedicated to rapid response for the user community. And that's it. Thank you.
Thanks. Thanks, John. That was very helpful, very informative. Busy year for you, and looking ahead, even busier next year. So, so any questions? I saw Rose had her hand up.
Oh, I was just going to go in there and say that was NSF that provided the mid-scale $6 and whatever million just to give us a plug.
Okay, okay. Sorry, Rose.
Right. I mean, it can't be a meeting without me saying something about NSF branding, but you guys have heard it a million times.
Yeah. I should have said NSF mid-scale research infrastructure. Yeah.
Congratulations.
Yeah, that's a big, big, big deal.
Right.
Sure is.
It is a really big deal. That's why I think we got to remember to add NSF in there so that outwardly we can demonstrate just where we're putting our money.
In the words of Joe Biden, it's a big fucking deal.
That was recorded, by the way.
Yeah. Thanks, Jim. That was
It'll get bleeped out.
Bleep you out. Okay, not seeing any other questions for John. Again, thanks for that great update, John, and congratulations on all the successes this year. Next up is Maureen Walzak to talk about the marine sediment sampling, or MarSSAM.
Hello.
Hi.
Thanks for joining us.
It's my pleasure to be here. All right. For those of you who don't know me, I'm Mo Walzak, and I am faculty at Oregon State University and the lead manager of the NSF-supported UNOLS Marine Sediment Sampling Facility, or MarSSAM. Our specialty is mud. And at last year's annual meeting, we gave a fairly detailed introduction to the facility and its staff and what we do. But at the risk of being redundant, I'm going to give the 20-second pitch here. We're based at Oregon State University, but we work with any vessel in the UNOLS fleet. We also occasionally work on contracted vessels, both within the US and internationally, as long as they're supporting NSF science goals. We consist of a team of 2 full-time and 2 part-time technicians. Paul Walzak cannot be trusted. Chris Fancher's pretty good. There's Dale Hubbard, who's very experienced and wonderful. And then our youngest gun is Ben Freiberg. So some of you may have met them. If you have not yet, I hope you do. They're all lovely. I do most of the clerical work for the facility, but we also provide logistical expertise for planning and executing of coring cruises. And so in addition to our salty team of technicians, we have seasoned oversight from co-directors Chris Goldfinger and Mitch Lyle. And we also have an oversight board that includes August members of the marine geology community from a number of institutions. Next slide. So obviously 2020 was pretty quiet for us, but in 2021, it appears the community is once again after mud, and we've been supporting coring operations on a variety of scales, on a variety of platforms. It's been a fairly unusual year for us because even our heaviest systems are being required for deployment from some of the smallest vessels we have ever worked on. So if you look at this list of vessels that we're supporting, this is not the typical MarSSAM list of customers. This is our first year supporting coring from the RV Pelican that I'm aware of. There's nothing shocking about multi-coring from the Pelican, and we supported multi-coring cruises by sending supplies earlier in the year. But now we are planning to attempt jumbo piston coring in support of a rapid response cruise to that recent earthquake in Haiti. And there are obviously some logistical challenges there with regards to the limitations of the free space in the fantail and the safe working load limits of the A-frame, given that jumbo piston coring is pretty heavy stuff. But the LumCon ship ops team have been really great, and we're going to give it the old college try and see how we go. Earlier this year, we also did a jumbo piston coring cruise from the Endeavor in the Gulf of Maine, which was quite successful. We built on recent successes, jumbo piston coring from the Oceanus, so that experience was really helpful there. And we've also picked up a little bit of external contract work supporting efforts on UNOLS vessels that are supported by the Bureau of Ocean Energy Management, or BOEM, and by the U.S. Army Corps of Engineering. So we did a little bit of Vibro coring on the Point Sur, and we supported a box coring trip on the Oceanus, both just providing technicians and equipment. In another first, as of yesterday, I think we can formally, Kai, you can correct me if I'm wrong, I think we can formally lay claim to supporting a Calcoffee Modern Ocean Observing Experiment. This is not typically the milieu of MarSSAM, but we have divested our seagoing lab van of its geotech multi-sensor core logger so that the West Coast van pool could rapidly retrofit it with modular benches and a sink and send it off to the Sally Ride. So lots of new stuff for us. Next slide. In early 2022, our attentions are shifting to the tropical Atlantic. Due to dubious career decisions in my youth, outside of managing this core facility circus, I moonlight as a high latitude paleoclimatologist studying ice-ocean interactions. So I've never actually been to the tropical Atlantic, but I imagine this is what it looks like. Palm trees, beaches, beautiful. So we're gonna in January of 2022 go out on the chartered RV Garvin with PI Donnelly and do some Vibro coring for storm deposits in the Bahamas, permits permitting. And then in February of 2022, we are going to support a jumbo piston coring cruise using what we're calling the astronaut coring system, but the coring system that was designed for the Armstrong and the Sally Ride. The Armstrong and the Sally Ride. It's actually not going to be aboard the Atlantis. It's going to be aboard the Armstrong. So next slide. And so this cruise is going to be a record-breaking cruise. Hopefully all we break our records. This is a news release from May of 2021, celebrating the recovery of the deepest sediment sample recovered in the Pacific, 8 kilometers down from the Marianas Trench or Japan Trench region. Next slide. And we're going to blow that out of the water. Next slide. I hope. Do we have a slide?
Hold on, it's trying. Oh, there it goes.
Yay. I spent a lot of time on this, guys. I'm a professional. So I hope everybody appreciates my graphics talents. I'm wasted on MarSSAM. We're gonna core to 8.7 kilometers water depth, which will be a new record to the best of our knowledge. But we're confident that we can do this with the Armstrong system. If we go to the next slide, this is a little just a little science nerding out here. So this graphic here is illustrating the location of the Puerto Rico Trench. And the Puerto Rico Trench is the deepest point in the Atlantic Ocean. It doesn't get as deep, obviously, as the deepest trenches in the Pacific, but we're going to get a core that's deeper than the deepest one that they just collected. So we're still going to break the record. It's kind of an interesting area. There's sort of like a lateral transform fault, but then there's also some subduction of North American plate, which is really interesting, but it's producing this really deep trench. And we're going to go down there with the Armstrong jumbo piston coring system. So this series of panels along the bottom, can I annotate so people can see my annotations? Let's see.
Probably not, actually.
Probably not.
Yeah.
Who needs annotations? Working from left to right, this is kind of the series of operations that the situation that we're in right now with some of the newer UNOLS vessels is that we don't have the capability to do over the side operations with our heavy cranes. And so we're having to adapt these coring systems working from the A-frame, which comes with some challenges. So the solution that was engineered by Jim Broda for the Armstrong and the Ride is to bring the coring equipment up through the A-frame, and just imagine it in reverse for deployment, and then to pick it up with the crane and swing it out around to the starboard side of the vessel into a second bucket. And so that move there is a little bit hairball. There's a lot of whip on that crane, but in good conditions, it's totally doable. And then once it's in that second bucket, then that bucket can rotate up along the side, basically replicating the advantages of working over the rail when it comes to having that access. So that's what we'll be doing. The one thing that we'll be modifying on this system for this particular application is the astronaut coring system does not have a mechanical trigger. It was designed with an acoustic release pinger, and that's going to be a problem at 8.7 kilometers water depth. It also could be additionally complicated by the fact that the bathymetry in that trench is really steep and echoey. So we're gonna actually modify this system with a mechanical trigger arm that's appropriate for use for synthetic. The ones that we use for our regular jumbo piston coring equipment are designed for the 9/16 wire, but we're working with this company in the UK, OSIL, Oceanographic Scientific International Limited. It's quite a name. But they build good coring equipment. They have been supplying our colleagues in Australia and China and Europe with wonderful piston coring systems, and we're going to be buying an off-the-shelf coring arm from them, so we can rig the Armstrong system up with a mechanical trigger. So next slide. We have expanded our inventory in 2021, which has been extremely popular. We have added Ocean Instruments RIC 4000 and RIC 5500 Vibro coring systems. We originally submitted a proposal just to acquire the RIC 4000, and then we were offered the opportunity to also acquire a lightly used RIC 5500 for a real steal, and so we were able to squeeze that into the plan. And between these two systems, we now have a lot of flexibility in acquiring cores from environments that are really challenging for our previous inventory of equipment. So Vibro cores are great for working with sandy sediments like turbidite sequences, ice rafted debris type sediments, well-sorted carbonate sands like you find in the low latitude Pacific. These environments that are really challenging for systems that rely on gravity and like just sort of shock loading into the sediment that basically reject our piston coring and our gravity coring systems. The Vibro coring system can kind of shimmy its way in there and allow for the recovery of really nice samples. And so these Vibro coring systems are advertised to recover up to 10-meter long cores. This image in the lower left here is a trial of the RIC 5500 system with Jeff Donnelly, who is some kind of black magic wizard. That's a 14-meter long core there that he pulled out of a lake using a raft. So we're working with him and trying to learn the tricks of that trade so that we can apply them to the UNOLS vessels. The systems between the two of them allow us to work from the smallest of the UNOLS vessels up to the very largest. The RIC 4000 is a full ocean depth rated system, so we can work to 3,000, 4,000 meters water depth with it. which is awesome for science. The RIC 4000 is hydraulically actuated, and so it requires less power to get it to shake, which means that we can deploy it from the electromechanical strength member, like the 680 wires that are on the ship, as well as using battery packs, which that versatility is great for use with synthetic line, et cetera. And then the RIC 5500, the coring system itself isn't appreciably different, but it's deployed with a cable. So its depth range is limited to a few hundred meters, but it's a much lighter system. It's better for what Donnelly refers to as stinger operations, shallow water depths, smaller platforms, et cetera. We've also resurrected the old Lumcon Alpine Vibro coring system that's been sitting in our lot for a few years. Our techs were bored during COVID, and so they started pulling it apart and hitting it with hammers, and they drilled a hole in our parking lot. So it's ready to go. If someone just wants to request it, you need a really big A-frame. I think this thing would be awesome to take on the continental shelf. It's just a beast. Okay, so next slide. Training and outreach. We have finally, after several years pending, been scheduled for a coring PI training aboard the Roger Revelle in August of 2022. We're going to be releasing the application process for that, hopefully prior to AGU this year. If you know of any PIs that are coming out with you that seem like they could use some help, we're going to try and prioritize funded NSF PIs who could really use this experience as fast as possible. And then I also want to encourage you to follow us on Twitter. We have, I think, like 14 followers, and they're all our friends. So we're trying to come up with an outreach presence that allows us to reach the community rapidly. Twitter seems to be the way to do that. Alice, can you play this video? Is it working? Paul and Chris are wonderful at coring, but they're absolutely not tech savvy. And they shot this video on the jumbo piston coring cruise on the Endeavor. This is on our it was rigged up as a gravity core in this instance. But keep your eyes peeled. Look at that. It's a blue shark. How cool is he? Right, he just checks it out for a while. He's like, oh, what are they doing? They want my mud? And then swims off. So they gave this away to the PI of the cruise to put it on her Twitter account. And Kat Allen got 20,000 views from this video. so maybe in the future we'll figure out how to get our act in gear and be the first people to post these neat images of the seafloor. Also, our website continues to be updated with our new inventory. That's our email address. Any questions?
Thanks, Mo. Your team does the coolest stuff.
I agree.
It's fun throwing big pipes into the ocean bottom and pulling up stuff.
Just one little bit of clarification, because many people don't know what the astronaut series means, or the astronaut cores.
Yes.
Go ahead.
We informally refer to the astronauts as the Armstrong and the Ride. So the Armstrong and the Ride have very similar configurations. Well, I mean, they're sister ships, right? So they have very similar configurations with how they need to be used to deploy coring equipment, and the coring system that was designed for the Armstrong is also adaptable to and has been trialed from the Ride. So if anybody wants to go jumbo piston coring from either of those ships, they would use.
It used to be called Long Core Light, but we got rid of that name.
It confused people.
Yeah.
So astronaut doesn't confuse people, right? It's clear as mud.
Right.
Yeah, right.
As mud.
Liz Sykes has a question. She loves to core.
Yeah, I always have a question about coring. So the photos that you showed of the astronaut system, I love that actually. So am I right? So you're coring with line off of both of those vessels, correct?
Yeah, synthetic.
And so yep.
It is
and
the way.
so but in the pull-in, obviously, so you're still using a it looks like you're using a wire down into the, I forget what you call that bit, the
pendant.
Yeah, and the pendant. So you're still using a wire pendant?
Yeah, they've been still using a wire pendant because they're concerned about I guess when it's under tension, the synthetic will part really easily if it hits a sharp corner. Mm-hmm. And so the solution they've come up with is in the parts that are likely to have contact with the vessel or rub against the inside of the barrel, they use a little shot of.
Yep. Yeah. So my question there is, the one time I used the line coring, we had a lot of trouble with the pendant just spooling on the way up. So how have you solved that?
This would be a better question for Dale or Paul.
Okay.
But I understand that they did some work with balanced lines.
Okay.
And so they found some kind of balanced cable that doesn't corkscrew.
Okay. No, I'm just curious because I realize there's just so many. What I'm trying to wrap my brain around is my experience, but also kind of wrap my brain around because there's so many small pieces to switching over to line. And I feel like you guys are getting at that one nice small piece at a time.
Sure are, Liz. But we'll get there. I mean, I really like, I know you're in the same boat, but synthetic is the way with all of the limitations that we have with regards to how hard we can pull on the 9/16 and, PIs wanting to work in deeper water depths where that wire weight alone can preclude pull-out tensions from a coring system. Like the synthetic is it's just the way. And we're getting
there's no way we'd be trying to core the Puerto Rican trench with 9/16 wire.
Impossible.
Exactly.
You couldn't even pull that much wire back.
Yeah. So yeah, just trying to keep up with the times on that. Thank you. It's great presentation. Looks like you guys are making great progress and doing very well.
Thanks, Liz.
Okay, thanks again, Mo. Now we're going to shift over to the potential fields pool equipment with Masako Tominaga.
Hi, can you hear me okay?
Loud and clear.
Awesome. Thank you very much. So hello, everybody. My name is Masako Tominaga. Today, I'm presenting activity updates on the PFPE, namely shipboard gravimeter and also magnetometer. Those are the potential field tools facility, kind of sub-branch of Hui Marine Ops SSG group now. And by the way, I like Alice's read ahead doc that summarizes what we do very well. So thank you so much for hosting this presentation format, Alice and Doug. So we are currently 6-people team and funded by Jim Hollick's program at NSF OC ISP. So thank you so much for Jim and the academic research fleet community for continued support. Our working partner is also the National Geospatial Intelligence Agency, who provides both BGM-3 and new gravimeters to the US academic research fleet community for science use. Next, please. So we know that these numerous COVID-related challenges put all the ship operators and sailing science parties in challenging spots for now 20 months or so. Even in this difficult time, with tremendous help and support from the UNOLS community, we PFPE could operate nominal 7 to 8 BGM-3 meters on these vessels, as we have been doing so previous years. So thank you so much for the shipboard tech group on the Sequoia, Crevel, Thompson, Lanxess, Kilomoana, Armstrong, Atlantis, Palmer, Healy, and also Ride, although her BGM-3 meters is, I believe, stored on shore right now. This 2 years, so the 2020 and 2021 collaborative endeavor allowed us to continuously collect invaluable marine gravity data during the transit, vessels transit, and also some science missions for greater science knowledge. A highlight of the year is actually that we able to launch and test a new gravimeter. So PFPE is awarded through Jim's program to acquire one DGS meter. Here, DGS stands for Dynamic Gravity Systems, which is a company located in Colorado. Their meter is basically ITAR-free and proven technology on military and industry vessels and airplanes. For example, I believe a Polar program uses it on the airplanes. So far, we procured Hui, procured one through Jim's funding, and National Geospatial Intelligence Agency procured 2. And the picture here on the left shows the kind of on the ground towards you. That's the BGM-3, the vintage, robust, reliable gravimeter, yet most of the parts are out of shelf life or out of stock. And then the behind that is our new DGS meter. This is the lab on Armstrong. And the right-hand side picture is a preliminary data comparison between BGM3 and the DGS. We're going to present this on the AGU talk. So throughout this year, we have successfully conducted four side-by-side tests, test cruises running BGM3 and DGS gravimeters in parallel. DGS company itself has been on their learning curve with us, operating these meters on academic research fleet, which turned out to be slightly more, how can I say this, courageous, operating in rougher sea than typical oil industry survey vessels do. So the meter needed to be adjusted, but the company has been extremely responsive. So we're working together for the best optimal operation mode of the meters on the academic research fleet. So this excellent collaboration with Armstrong and Thompson produced data for QA/QC and also highlighted new operational practices and challenges to overcome, all of which we are currently tackling. Next, please. Okay, so for the rest of the year into next year, we will make sure that BGM3 will be continued operating and providing the reliable gravity data to the community. Our priority is make sure that Securiac meter will be recalibrated. And we have been in touch with Eaton's group. And we are a little bit low on the supplies. So to continue operating BGM3 for the foreseeable futures, we might need a little bit more new gyros on hand. So currently, also collaboratively troubleshooting a meter on Palmar that is underway to Punta Arenas, Chile. So we are going to monitor, maintain, and help to run BGM3 meters. In the meantime, we think that 2022 is still a year for the testing the DGS meter before widely disseminate its operation capability to the community. So we have gotten the good news that explicit commitment from NGA that they are willing to put one of their meters on the UNOLS vessel. So we have at least two to test continued long-term operation of these new meters. So we will be closely communicating with operators to see which path in 2022 schedule will be the best test case for us and everybody. So with the a little bit more effort for assessing the DGS data. So we will have one presentation by Hui and also by the manufacturer NGA and also the DGS at the AGU. And we would love to closely communicate with R2R for data archive because of the differences of data format and the processes, acquisition and then post-processing. We will be needing their help and then also our initiative to make the smooth data pipeline happen. Next, please. So Alice, could you click next? Thank you. Last slide on the fourth one. Oh, clogged. Okay, thank you. So there is going to be a little bit of a change in terms of the managerial roles at PFPE here at Hui. So I will be soon back to a science role here at Hui and trying to take over the management and the oversight role from Dan Fornari. I'm still on a learning curve, so please bear with me if I'm not responsive as Dan has been able to. But also I'm heavily relying on the very talented engineers here at Hui So Tom Lanigan, he's electrical engineer, the mechanical engineer, will take over the PFP's first responder role from Randy Haar, and who would be officially retiring at the end of this year from the PFP effort. Steve Falochko, he is electrical engineer, will be seconding Tom. We have this new member, Jasmine Zhu. She is a mid-career research associate here at WHOI, extremely data savvy geophysicist, and she is mainly assessing the DGS data pipeline and also developing a best data handling practice, hopefully with R2R soon. We are overdue to update our website, which is supposed to be the first entrance of any SSSGs on board the vessel to understand what PFP does. So we are working on it and try to publish the new website in early 2022. We are always here to help this great effort. You see this email address, pfpinternal@hui.edu. So one of us will try to respond that as soon as possible. And again, thank you so much for your help, for continued support of PFPE. Thank you. Thanks, Alice.
Thanks, Moscow. Appreciate that. Very helpful update. A lot going on in your world too. Any questions for Moscow or the PFPE team? Okay, and somebody posted the email in their chat for if you want to reach out to PFPE.
Sorry,
posted that.
Yes, I misspelled. It's not the underscore, it's a hyphen. PFP hyphen.
Very close.
Thanks, Tom.
All right, good catch.
It's my bad. It's my bad. I told you I'm a learning curve.
Okay. All right, thanks again. Appreciate it. Now we're going to move on to the portable seismic system update with Lee Ellett from Scripps.
Hi, Lee Ellett with SIO, updating on portable MCS. Next slide. So I don't have much to report. The two cruises that have been in the works, the one with the Justo Sierra have been deferred, but we're looking forward to supporting this in next year in 2022. And then there's also potential project in late 2022 on the Palmer. So luckily we've been able to support the staff on other projects as we've been fairly busy, some with multi-beam projects and some other hardware installations. Next slide. The one thing I do have good news about is that we are going to acquire 2 portable compressors. So I want to talk a little bit about the selection criteria that we used and in the proposal to obtain the funding to do this. And we collaborated with current and former users of the system to determine what is the widest range of compressor that we could get, to support the widest range of projects. What can we get to that would be the most impact for portable compressors? So we developed this list and we worked with a number of vendors. So we can go to the next slide.
Somebody could mute their speaker, their microphone, please.
Yeah, so just the final slide here, so maybe pretty brief, is that so we're currently working with UCSD procurement to get these purchased. Funding arrived in late August, and so that's where we're at now. But for planning purposes, if on the larger global and ocean class vessels, it should be able to carry 2 of these systems for redundancy, or for if they're for potentially larger projects. And then smaller vessels that have less range and endurance, 1 compressor is probably going to be sufficient. So it still keeps us in a wide range of vessels that could potentially conduct portable MCS projects. So yep, more on that when we're able to as we get these procured and tested going into next year. And I'm happy to take any questions that you might have.
There's one question in the chat there.
Oh yeah, 385 SCFM.
LMF.
Yep.
Great. Well, thanks, Lee. That was quick and but very up to date, and appreciate all the work that's going into the acquisition of the compressors. It takes a lot of work behind the scenes too to make that happen. So thanks for your efforts. Any other questions for Lee? With that, and we'll turn it over to Dan Fernari to talk about MISO.
Okay, thank you very much. Just hang on a second. I will try to share my screen and see if this works.
There we go.
Alrighty. So hopefully you see that okay?
Yes.
Yep. And presentation. There you go.
Let me just make sure to do it that way. Okay, so we're all good. You can see that okay?
Yep.
Great. So let me just say in advance, as a science user, I too want to express my thanks to all of the facility operators within the academic research community. We clearly can't do our work without this great support that we get from everyone and from all of these different types of facility support folks. To the agencies for supporting their work. It's truly unique in the global community to have this kind of support, and it really makes a big difference in terms of how productive US scientists can be. So I just wanted to express my thanks from a science point of view to everyone here involved. So really, really appreciate it. Okay, so onward to the MISO facility. I'm just going to give a brief sort of review of what we've been up to. 2021, as other folks have noted, has been challenging in terms of trying to make things happen with COVID and various sort of constraints that's imposed. But we have been pretty active in helping to support a variety of science operations, mostly related to imaging and mostly related to deep submergence. Here you can see these various cruises that have occurred during this year. I think I chatted last year about the cruise that we supported with multi-coring on the Kila Moana with the MISO imaging systems. So I didn't go into that this year, but this year it's been largely supporting deep submergence operations using Jason and Sentry, and then hopefully soon to be Alvin when it begins operating again this fall. And I just wanted to sort of shout out to Mo that I am continually interested in sort of connecting on imaging on multi-coring. I know that there's a couple of programs that are coming up, and I will be wanting to talk with you and the other sort of facility operators about that. I'll make a mention of how I've been adapting some of my systems to better support those activities in the next slide. Okay, so let's see now, how do I get, okay, all right, so now, all right, so clearly, how do I share, oh, let's see, there I go, oh, sorry. All right, so ongoing facility work. So one of the things that I've been up to is, as I just mentioned, creating sort of modular subsea cabling systems for various multi-core configurations. The Brian Haley cruise pointed out that we really needed to have some different sort of options for imaging that didn't necessarily have real-time imaging, but provided some imagery capability. So we've done that, and we've actually, with Jim's support, been able to put together some subsea cabling configurations that will greatly facilitate that. So I'm looking forward to helping to support more multi-coring imaging. We also can support box coring And that is something that I want to make sure to chat with Mo and her folks about, and other operators that are operating box scores, because we can put remote cameras on there so that the folks can see what it is that they've cored after the fact. We've also been developing time-lapse camera capability using LED lights and various MISO cameras. That's been pretty important for work at the EPR, both for biology and for hydrothermal studies. So we are continuing to do that, working closely with some of the graduate students involved in the Molyneux, Arellano, and Vitriani group that is doing some very detailed studies of some of the small critters, both in the sort of extinct hydrothermal sites as well as the active hydrothermal sites there. We've also been working on refurbishing and recalibrating and making some slight design changes to the high temperature loggers for vent studies. That work has been very successful. The work that we did at the EPR, we deployed 13 loggers and recovered 8 of them. And we've got a fabulous time series going that's helping us to understand the lead up to the next volcanic eruption, which we predict, hope is going to happen in the next few years. Anyway, that's part of what we're sort of continuing to do for next year. At least based on what we know or understand the Atlantis Alvin schedule to be, there will be a couple of cruises at the EPR, hopefully. It's still a little TBD, but we think that this is approximately when they might happen. We're going to be working to help support the camera operations on Alvin with the MISO imaging systems, and also for time-lapse work, again, for some of the students involved in with those PIs. And again, supporting camera operations on Alvin, both with landers and time-lapse systems, as well as imaging from Alvin. I'll show you a little bit of that in the next couple of slides. And then, as I mentioned earlier, from looking at some of the schedules and funded projects, it appears Lisa Levin and Mandy Joy have some operations that they've requested multi-coring as ancillary or to some extent primary sort of data collection activities during some of their deep submergence ops. I don't know when they're going to be scheduled, 22, 23, I don't know, but we're certainly interested in helping to support that and to expand their sort of data collection and capabilities. Okay, all right, so this next one is just a very brief slide to sort of highlight what we did with Jason. These images that you see on the left, so that's one of the MISO cameras right on the brow of Jason, taking images every 5 seconds of the work area and documenting that at high resolution at 12 megapixels. And then we also developed a side-by-side 4K camera and digital still camera that's mounted on the manipulator. And then we used a small DSPL IPC cam as the viewfinder camera. And the imagery from that is spectacular, with really very novel perspectives on how you would image various seafloor processes. So that's been terrific. We also were able to collect still images, 24 megapixel still images with Sentry. It's the best, highest resolution data set collected with Sentry ever. And we're looking to expand that in the coming year with possibly collecting video as well. So that's something that, again, we're trying to make the systems modular and adaptable. And that includes being able to use it not only on deep submergence vehicles like Sentry or like Jason and Alvin, but also to adapt it for the ability to use it on Sentry autonomously. Okay, and then, all right, so what you're seeing here, the video is just going to run, hopefully. You're seeing that. So this was taken from a lander that I put together at the EPR. That's Jason heading towards Tika vent, about 2,500 meters depth. That's 4K imagery, although it's been downgraded so that it wouldn't bog down the transmission to 1080p, but it's 4K imagery. On the left, you're seeing one of these perspectives from the manipulator camera, and that's sort of looking from above and down sort of right into the throat of one of these vents that we're sampling hydrothermal fluids from using the major sampler. Again, it's provided just an enormous amount of valuable information in terms of characterizing the hydrothermal processes and the volcanic processes there. And then on the lower right, there is a 24 megapixel still image from collected by Sentry. We collected these on I think it was 7 Sentry dives that were dedicated and had photo transects. And ultimately what we're doing is trying to correlate the bottom texture and terrains that we're seeing in the high resolution still imagery with the 50 centimeter resolution Sentry side scan data and 1 meter resolution bathymetry data that we've collected along the East Pacific Rise from about 945 to 957. So it is the largest near bottom multi-beam data set collected anywhere on the planet. It's been processed. The manuscript was just submitted to G-Cube. There is a DOI for the data that is in MGDS now, as soon as the paper gets published, we'll basically go live. So we've made that available to all the PIs working at the EPR, and so they have the latest and greatest bathymetry data that has been developed for the East Pacific Rise 950 North area for whatever studies want to be done. Okay, these images, they are pretty images and they're pretty cool, but they're also pretty useful because, for instance, we pointed out to the Jason operators and pilots that their swing arms don't really come in when they're operating on the bottom. It's partly a flotation issue and maybe a mechanical issue, but it's something that they need to be aware of when they're moving around. So these things are not only useful in terms of giving both scientists, operators, and the layperson a perspective of what vehicles are doing down on the bottom, but they're also very useful in terms of helping to refine the operational sort of procedures. All right, and then finally, we're working hard on continuing to support researchers as we can, and when we find out that their programs have been funded and what kind of capabilities they need. We've been doing repairs on some of the systems, although in general things are working pretty well, but we've been doing a variety of sort of routine maintenance on the batteries, the electronics, the cameras, and whatnot. We're going to be providing supplemental cameras for the NDSF vehicles for sure, and as necessary and required when we can, and if we have enough if we have enough cameras available for other vehicle systems as well by other operators, as we've done in previous times, both with Hawaii on the Pisces vehicles and with Falcor and also the Ocean Exploration Trust vehicle. One of the things that I really would like to do, because the MISO GoPro cameras are based on a Hero 4 module, imaging module, which is now discontinued to the point that you can't even find them on eBay. We're still keeping all of that going, and it's working quite well. And we've got spares, but we see that we really need to go to the next sort of stage and modernize that imaging module, but maintain the same flexibility. So in my copious spare time, I'm trying to work on that, and so is Eli Perrone, the principal engineer at Ocean Imaging Systems. So that is definitely on the front burner for us. We've also been collaborating with Shannon Hoy and her group at NOAA Ocean Exploration for testing and developing a routine camera capability for Okeanos Explorer for them to use. And again, this is based on the MISO TOCAM system, which Shannon has had some experience with on a couple of cruises. So we're working on a proposal for that's going to go into NOAA OECI very shortly, and hopefully they'll be doing a test of that on one of the transit cruises and engineering cruises that they have in April of 2022. And in addition, and finally, I am working with Andy Bowen and others here at WHOI to try to more structure better a transition plan for how to transition the MISO imaging capabilities into the future, with the idea that at some point in time, I am going to stop doing a bad job of retiring and really retire. I don't know when that's going to be, but probably a couple of years. But in any case, it's something that I'm trying hard to do. And as you've seen from Rian's sorry, from Masiko's presentation. She's graciously accepted to take over responsibility for PFPE, and I'm going to continue to help as I can. But it's in very good hands with her and with the other engineers, with Tom and with Steve and the other PFPE folks. Okay, happy to take questions if you want. Sorry to be a little long in the tooth, but.
Thanks, Dan. Great video, great pictures, highlight the great work you guys do there. So thanks to the update and all the hard work and the fact that you're not haven't retired well yet. Everybody's enjoying taking advantage of that.
Okay, happy to help as usual.
So I don't see any other questions. So obviously you dazzled everybody with brilliance again. So that concludes all our talks for today. We're going to get together again Monday again, same time, 4 o'clock Eastern, 1 o'clock Pacific, talk about outreach and satellite communications. I'm going to turn over to Dennis Hansell real quick here to help us conclude today's session. Again, thanks to everybody for joining us, and thanks a lot to the presenters for your great updates today.
Thanks, Doug. Hey, this was a wonderful bunch of presentations. I didn't know what to expect this time around, but it was like such a thrill to hear about our capabilities, and it made me very proud to be part of this community. It's amazing. And the really important thing to note is Jim Hollick's fingerprints all over these successes. Jim, thank you for your dedication, your professionalism, and for your use of the French language on occasion.
I'm going to retire before Dan does.
Sure, yeah.
Uh-huh.
No,
yeah,
seriously,
we'll see
Jim,
about that.
Jim, you're so important. So thank you so much. Thank you. Fantastic. All right, I guess that wraps it up, everybody. Alice, Doug, when do we meet again? Monday?
It's Monday.
Same time.
Same time, same place, everybody.
Yep.
So yeah, next Monday is also the RV Tech meeting. So we're doing our annual meeting on Monday, and then the RV Tech meeting is going to be the rest of the week if anyone's interested in any RV Tech business.